Hello there. So let's continue to learn about Kubernetes. We are in the services section, and here we have the tutorial called Connecting Applications with Services. Let's read a bit. This introduction is important actually. Kubernetes assumes that pods can communicate with our pods regardless of which host they land on. So on which nodes. This is not important. Kubernetes gives every pod its own cluster private IP address, so you do not need to explicitly create links between pods or map containers pods ports to host ports. This means that containers within a pod can all reach each other's ports on localhost, and all pods in a cluster can see each other without network address translation. The rest of this document elaborates how you can use reliable service on such a networking model. So that's great. In short, Kubernetes handles all this communication between pods, non-regardless of which node on which node it's scheduled, and the pods inside the container inside the same pod can communicate each other using the local host and the port number. Great, so let's go over exposing pods to the cluster. Here we have a deployment called MyNginx. It has a label run MyNginx, which has two replicas and Nginx image with container port 80 exposed. I am using Minikube, so I will create a file called MyNginx YAML. Actually, I have created it beforehand, so you can paste here the content. I have already done it. So pods, I don't have any pod yet, so I'm applying this resource k apply f my nginx k get pods, and the pods are creating. And we can do this label signature to get specifically the pods with this label, MyNginx white. We are getting the IP addresses and the node on which it's scheduled. Here it's interesting actually that we can use a custom column to output. So by using the -o, which is the output flag, we can use these custom columns and give a key value how we would like that output to look like. So here we have the value, the name of the column pod IPs, and the value is taken from the status pod IPs subsection. Okay, describe deployment MyNginx. So if we are describing the deployment, we can not the deployment, but the pods. Let it be. So we can see that the pod has status and IP. So it has kind of a list of IPs. Here it has this IP 70. That's where we have taken from this status .pod IPs. So the signature is a little bit different, but that's one way how we got it. Okay. Here we have more information. You should be able to SSH into any node of your cluster to use the tool/curl to make query against both IPs. Note that the container are not using port 80 on the node. There are any special NAT rules to route traffic to the pod? Yeah, that's by default. Everything is like just working out of the box. This means that you can run multiple Nginx pods on the same node, all using the same container port, and access them from any other pod or node in your cluster using the assign IP address for the pod. If you want to arrange for a specific port on the host node to be forwarded to baking pods, you can, but the networking model should mean that you do not need to do so. And here we have like more information. This is about IP ranges. We have clusters, services, pods, nodes, network types. Yeah, quite interesting. So let's go. Next, creating a service. So we have pods running Nginx in a flat cluster-wide address space. In theory, you could talk to these pods directly, but what happens when a node dies? The pods die with it, and the replica set inside the deployment will create new ones with different IPs. This is the problem a service solves. Yes, indeed it is. A Kubernetes service is an abstraction which defines a logical set of pods running somewhere in your cluster that all provide the same functionality. When created, each service is assigned a unique IP address, also called cluster IP. This is the default, by the way, cluster IP. This address is tied to the lifespan of a service. So when you create the service, that cluster IP is stable until the service won't be deleted and will not change. Service alive. Pods can be configured to talk to the service and know that communication to the service will be automatically load balanced out to some pod that is a member of the service. You can create a service for your two Nginx replicas with kubectl kubectl expose. Yeah, so if you are doing kget SDC, yeah, we have already one because okay, that's another service. This is old one. I can delete. See, not related to this tutorial. So we can create a service where we can create a file. I will use kexpose deployment my Nginx kget service. So it has created, because we haven't specified which kind of service we want by default, it uses the cluster IP. This is the allocated cluster IP, which is not changeable until this service won't be deleted. And we use default 80 port exposed. Okay. Yes, here we have it. So as mentioned previously, a service is backed by a group of pods. Yeah, so we have this service which exposes this IP outside and routes all the traffic which is coming through this IP to one of the pods behind this service using some load balancing given. And here we have like these ports are exposed through endpoint slice. So endpoint slice tracks the IP addresses of pods for services. So the service selector will be evaluated continuously and the results will be posted to an endpoint slice that is connected to the service using labels. Label selector. When a pod dies, it is automatically removed from the endpoint slices that contain it as an endpoint. New pods that match the services selector will automatically get added to an endpoint slice for that service. Check the endpoint slice. Okay, so describe SVC Nginx. So this is the endpoint. Okay, good. This is the endpoint slice. Here we have the slice, a list of IPs of the pods which are being served by this through this service. Get endpoint slice, endpoint slices. Here we can see this endpoint slice, which it's named. It has a type of the address. It's IPv4. It has ports, and we have like 2 endpoints, which are those one. Here we have the port, but here only the. So under the hood, like services have in its implementation have endpoint slices, and they are updated. When we scale, we create more pods. Those slices will be, those new IP's address will be added to this slice. If we are deleting or the pod is dying and a new one is created, that slice will be updated. So the service will redirect the traffic to the new IP address. And that's quite interesting. Yeah, here we have endpoint slices. Even we can use this label annotation. And yeah, we see it. That's great. Let's go to the next step, accessing the service. Kubernetes supports 2 primary modes of finding a service: environment variables and DNS, domain name service. Domain name system, I think it's called. Yeah, domain name system, excuse me. The former works out of the box, while the later requires core DNS cluster add-on, which it's kube add-on list. In my Minikube, I don't have, actually I don't see here. Maybe it's not enabled. That's also possible. If the service environment variable are not desired because possible caching with expected programs want too many variables to processes only using DNS, can disable this mode to enable service links flag to false. Okay, some extra information here. Environment variables. So let's look at the first one. So when we are executing into Nginx, yeah, can be this one. We have dash, which means this printf and subsequent commands will go inside the serve, inside the pod we are now executing. And here we have a different order. We have port 443, HTTPS, and this is the host. There is no mention of your service. This is because you created the replicas before the service. Another disadvantage of doing this is that the scheduler might put both pods on the same machine, which will take your entire service down if it dies. We can do this the right way by killing the pods and waiting for the deployment to recreate them. It won't work on this machine at all because we have only one node. This time the service exists before the replicas. This will give you scheduler level service spreading of your pods, provided all your nodes have equal capacity, as well as the right environment variables. Interesting. So the order matters. We have created the deployment first and then the service, and that's it has some disadvantages, yeah, that can cause communication issues. So let's follow. Here we are doing scaling. Basically we are trying to scale down, so delete the pods and creating them again. It will be on the same pod and same node, I'm sorry, because we don't have our get nodes. Yeah, no chance. So okay, get pods, I'll run nginx output wide, and we have new IP addresses assigned. So if we are doing the same execute, but of course the name of the pod changed, you can see that the hash is the same, but the unique part has been changed, and we have here a new data. This is the port HTTPS, sorry, is the HTTP port. This is the localhost address, and we have a new one, the MyNginx service, MyNginx service host. Since now the service was existing before the pod, the deployment itself. Okay, let's go to the DNS part. Kubernetes offers a DNS cluster add-on service that automatically assigns DNS names to our services. You can check if it's running on your cluster. I don't think I have here. Oh, actually I do have. And it's not in the add-on. Okay, yeah, maybe something changed. So we have also DNS called kubedns here working. The rest of this section will assume that you have a service with a long-lived IP, MyNginx, and a DNS server that has assigned a name to that IP. Here we use the core DNS cluster add-on application name kubedns. Yeah, we have it. So you can talk to the service from any pod in your cluster using standard method get hostname get by hostname. For example, if core DNS isn't running, you can enable refer. Yeah, we don't need this actually. Let's run another curl application to test it. So this is an ephemeral pod, ephemeral because we're creating a pod named curl. We have this image, and we are interactively like shelling in it. This is the TTI shell, and with the flag remove, after we will exit from it, it will be deleted, the pod. So magic is happening under the, I think some pulling, or yeah, I suppose so. Let's wait a bit. Error image pullback off. What? Looks like this. Okay, this image is not valid. I will do different. I will just use the BusyBox. BusyBox without any plus, just BusyBox. Okay. Okay, get pods. Here we go, some debugging. Okay, delete pod curl by curl. Let's do this BusyBox part. Okay, great, we have it, so we can check it. again, and it's running. So looks like this image name, it's outdated. You don't see a colon, try pressing it. We have it. So let's do this ns lookup my nginx, and we have it. This is the IP. This is DNS port 53, and this is the DNS, the name of the service, the name of the namespace, then .service cluster local, SVC. So let's continue securing the service. We will try now to expose HTTPS service by generating the key and certificate. First of all, we will need to create those keys and certificates. To do so, I will use this command, which is in this subsection exposed. I'm fixing the paths, so we are using OpenSSL utility to generate the certificate valid 1 year with RSA algorithm, and the output is going in the nginx key, and the certificate in nginx.crt, and the subject is company name and organization. And when I'm listing, I have 2 files. Now we are going to create a secret, create secret, and we have different type of secret. We are interested in TLS. If I'm doing help, here I have used this example, and I can learn, if I don't remember, remind myself how to create a certificate. First, we need to a TLS secret. Here we have nginx CRT, and then we need the key to be passed, and it's nginx key. Now we forgot the name. I forgot the name actually, not we. Nginx secret. Get secrets, and we have it. Now we will need to create a config map. For that we will need the file, and the file here is suggested to be taken from this repository. We are interested in this default config value. We'll create default conf, paste the value for configuration of nginx, and we are closing it. Now let's create create config map nginx config map from file, and we are giving this file get config maps, and we have this config map created. We will describe it, and we can see that this is the content of this config map. Here we see a different way of creating the certificate, the secret, basically generating the certificate, and then taking the output and encode it in base64, the key certificate, and paste it in this YAML by replacing this value with base64 encoded, and this also will work. Now here we have a definition of the nginx HTTPS deployment and service. The service, here it's important to note that we use node port, and we have 2 ports. We have HTTP and HTTPS, even they are named, so to be easier to distinguish. And the selector. The deployment is nginx deployment with 1 replica. It has 2 volumes. The secret which we have created, and the config map for the configuration, and 1 container which has this image. And by the way, this image is not working, at least on my computer. I'm getting error pull and crash loop back off. because it contains some outdated Docker schema versioning, but that's not important. I will use standard Nginx official image and it will work. So here we have two ports, HTTPS and HTTP, and the mount of the secret and the config map. So I will create the file nginx secure app-yaml. That's weird. I will copy the content, I will paste it, and do not forget to modify the image to use only the nginx. Let's go in insert mode and escape, semicolon, wq, and it's nice and working. Here is some information to delete the previous deployment and service. I have already done it. So here we have to create, I will use apply -f nginx secure YAML, and get pods svc, and we have this pod which is running on this service of type node port, and we have here exposed the ports 8080 HTTP and HTTPS, and here is the custom columns output format to get the IP of the pod. By the way, I have only one node here, so this one it's not working. And here actually it's interesting, this k parameter, which I haven't find in the, if I'm doing curl help, I don't see here k, but here they have it somehow. This is because we don't know anything about the pods running nginx at certificate generation time. So we have to tell the curl to ignore the CNAME mismatch. By creating service, we linked the CNAME used in the certificate with the actual DNS name used by pods during the service lookup. So let's test this one. Actually, this is interesting. Let's test this from a pod. So we will create a pod, and from that pod we'll try to hit this nginx application. Here we have a new deployment, which is a curl one replica. It runs in a loop just to keep it running, and this image is also not available. Not available. I'm getting again some error pool. Yeah, so for that reason I will curl YAML. I will use the official, actually not official, I have googled around and found some image which has curl, so I will try to use this one. And yeah, this curl mounts our secret, which means it has access to the certificate and the key which we have generated, and that's important. Let's apply file curl get pods, and we have two pods, nginx and curl. And here we have, like, we can now do this magic. First of all, k exec curl, and I will do interactive, and I will shell in it. So I'm inside now curl pod. I will use this curl command, which is we are curling the nginx service, and we have the certificate path file reference to the certificate which we are having from the secret. And when I am hitting indeed, it works HTTPS. So we have secure communication. That's pretty cool, I would say. And let's go exit, clear. Let's go to the last part of this tutorial, exposing the service. So for some parts of your applications, you may want to expose the service onto an external IP address. Kubernetes supports two ways of doing this: node port and load balancers. The service created in the last section already used node port. Yeah, good. Let me see this one. So when Nginx HTTPS replica is ready to serve traffic on the internet if your node has a public IP, which yeah, it has. It's interesting, this command. Let's get it here. So get service by Nginx, output as a YAML. Let's get the output as a YAML first. So we get the entire specification, and we are grabbing node port. Node port is here, and count 5. So node port, I think, is they're both node ports. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So yeah, and the following 5 lines. Great, we have it. And we have also external IP. But we don't have external IP because because this is Minikube. So yeah, no external IP here. But if you would have, we were able to use the external IP, node port, and curl